Picture this. You are walking through a place that was once alive with people. The echoes of voices are gone. Towers that once reached into the sky now stand hollow, glass broken, vines weaving in and out, like threads stitching nature back into place. The roads beneath your feet are cracked, no longer black but gray, soft with moss. A tree grows where a traffic light once stood. Birds have made nests inside what used to be offices. It feels quiet, almost peaceful, but also eerie, because only a short time ago this was a city. Imagine returning not in 100 years, but in 1,000. The buildings have collapsed. The concrete has turned to rubble. The forest has thickened, spreading across every street. The memory of human presence is fading. Now stretch further. 1,000,000 years pass. The rivers change their course. Sediment buries what remains. The earth folds and shifts, pushing parts of that old city deep underground. In another 10 million years, mountains rise and erode. Oceans advance and retreat. The city is no longer a ruin. It is gone. Its story has been erased. If this could happen to us, what if it already happened before? What if we are not the first? Not the first to build, to explore, to wonder? What if, long before our pyramids, long before our maps, even long before our species appeared, there was another civilization here? One so old that the earth itself forgot? It sounds like science fiction, but the question is real. Scientists and philosophers sometimes ask it, not because they believe in lost continents or myths of Atlantis, but because of something simple, something undeniable. The earth is ancient, and human civilization is astonishingly young. Think of what we call ancient history. The pyramids of Giza were built about 4,500 years ago. Stonehenge was raised around 5,000 years ago. Farming villages in Mesopotamia appeared perhaps 10,000 years ago. These numbers feel vast to us. They are older than our countries, older than our languages, older than almost everything we recognize as culture. And yet, in the timeline of Earth, they are almost nothing. The Earth is not thousands of years old. It is 4.5 billion years old. That is 4,500 million years. Try to picture that span. If the entire history of Earth were compressed into a single calendar year, humans would arrive in the final minutes of December 31st. Civilization, all of it, from the first villages to spaceflight, would appear in the last few seconds before midnight. The rest of the year would belong to oceans rising and falling, continents colliding, volcanoes erupting, asteroids striking, and strange creatures roaming through jungles, deserts, and seas. This is the stage on which we exist, a stage that has been cleared and reset countless times. Continents like Pangaea have formed and then torn apart. Oceans like the Tethys have disappeared completely. Mountain ranges have risen taller than the Himalayas and then crumbled into dust. Ice ages have swept across the land, carving valleys and burying entire regions. 5 times mass extinctions erased most life. If the Earth can erase so much, then why should we assume it has never erased a civilization? The Earth is not a careful archivist. It does not save every story. It keeps fragments, accidents, and lucky moments. The rest is lost. Fossils, for example, are rare miracles. For a living thing to become a fossil, it must die in just the right place, be buried quickly, and escape the hungry mouths of scavengers and the slow work of decay. Even then, minerals must replace the bones, and the rock must survive long enough to be found. Out of the countless creatures that have ever lived, only a sliver are preserved. Dinosaurs ruled the Earth for over 160 million years, and yet their fossil record is incomplete. We know them through scattered bones, a few remarkable skeletons, and impressions in stone. For every fossil in a museum, millions of creatures left nothing. If this is true for life, what about civilizations? Imagine our world abandoned. Within decades, plants split roads apart. Within centuries, steel rusts, wood rots, roofs collapse. Within a few thousand years, even stone monuments wear down. The pyramids themselves, if left untended for a few million years, would erode until they became part of the desert again. In tens of millions of years, tectonic plates might swallow entire regions, dragging them deep into the mantle. This is not theory. It is what the Earth already does. Cities have vanished in far less time. Pompeii was buried in a single day under volcanic ash. The city of Petra in Jordan, once vibrant with life and trade, was swallowed by sand and hidden for centuries until rediscovery. Angkor Wat, once the center of a great empire, was overtaken by the jungle within a few hundred years. In the Mediterranean, the city of Heraklion sank beneath the waves, forgotten until divers stumbled upon it more than 1,000 years later. These are places only a few centuries or millennia old. They feel ancient to us, yet in the scale of the Earth they are moments, heartbeats. Scale that up to millions of years, and survival becomes nearly impossible. Even our strongest inventions are fragile when measured against deep time. Concrete crumbles, iron rusts, plastics break apart under sunlight and heat. Satellites fall back to Earth. Even glass, which seems durable, weathers and erodes. Leave our world alone long enough, and almost nothing recognizable will remain. Scientists have thought about this. In 2018, Gavin Schmidt and Adam Frank published a paper that asked a bold question. If another civilization had existed millions of years ago, would we even know? They called this the Silurian Hypothesis, named after a fictional race of intelligent reptiles. Their answer was unsettling: we might not know at all. The traces of cities and machines would be gone. The only hope would be chemical fingerprints left in the rocks, changes in carbon levels, unusual isotopes, artificial molecules that nature does not make. Even now, our own fingerprints are being written into the Earth. Geologists call it the Anthropocene, the age of humans. Plastic particles are sinking into the seafloor. Concrete is mixing with soil. Nitrogen from farming is altering ecosystems. Nuclear tests have spread radioactive isotopes worldwide. If some future intelligence studied the layers of rock millions of years from now, they might find these signs. They might wonder what kind of beings left them, what kind of world we built, and why it ended. But the deeper truth is this: absence of evidence is not evidence of absence. Just because we have not found proof of another civilization does not mean there never was one. It may simply mean that the Earth has done its work too well. This possibility unsettles our sense of uniqueness. We like to think of ourselves as the first and only. It comforts us to believe that history begins with us. But Earth's age suggests otherwise. Perhaps we are only the latest in a cycle. Perhaps civilizations rise, flourish, and fall, leaving only faint echoes before being erased. Think of the Earth as a book not carefully preserved in a library, but one that rewrites itself. The pages are stone and water, some lines survive. A fossil here, a coal seam there, an ice core whispering of old climates. Most lines are erased, rewritten, and lost. What we hold as history is not the whole book, but fragments. Entire chapters are missing. And so, when we ask whether we are the first civilization, we are not asking about myths or stories. We are asking whether the missing chapters of this book might hold more than we know, whether buried beneath layers of stone are traces of worlds older than memory, older than myth, older even than us. This is the question beneath our feet. It is not fanciful. It is not simple. It is the natural question that arises when we treat time with honesty. A question that requires us to look beyond centuries and millennia and think in millions of years. Before we can search for answers, we must first understand the scale of the stage. A stage measured not in human lifetimes, but in billions of years. A stage where oceans move like wandering actors, continents shift like slow scenery, and life itself plays brief roles before fading away. That stage is called deep time, and it is where our journey now begins. To understand the possibility of lost civilizations, we must first face something far larger than ourselves: the sheer scale of time. Not the time you measure on a clock, not the centuries you read about in books, but geological time, the deep time of the Earth. Deep time is almost impossible for the human mind to grasp. We live in moments, in years, in lifetimes. We can imagine the span of a century, perhaps picture the rise and fall of an empire over 1,000 years, but millions of years, billions. Those numbers are so vast that they slip away from imagination. Think of it this way: if the history of the Earth were compressed into a single day, 24 hours. Humans would appear only in the final seconds before midnight. Everything we call civilization, the pyramids, the Great Wall, space travel, would happen in a fraction of a second, so short you might miss it if you blinked. The rest of the day would be filled with oceans rising and falling, continents drifting across the planet, and life transforming again and again into shapes almost unimaginable. The Earth is about 4.5 billion years old. That number is so large it is easy to let it pass without weight. But stop for a moment. 4,500 million years. Imagine stacking every year as a page in a book. The story of humanity would fit in a few pages at the very end. The rest of the book, tens of thousands of thick volumes before it, would be filled with eras we barely know. Entire chapters would contain worlds without a single human being, or even a creature resembling us. What filled those chapters? For billions of years, life was microscopic. Tiny cells floated in oceans under skies without oxygen, stromatolites. Layered mounds built by microbes rose in shallow seas more than 3 billion years ago. They still exist today in a few remote bays, quiet living fossils that remind us how long life existed before complexity began. Then, around 600 million years ago, life suddenly blossomed. In what scientists call the Ediacaran period, strange soft-bodied creatures appeared, unlike anything we know. Soon after came the Cambrian explosion, about 541 million years ago. In a blink of geological time, oceans filled with diverse life. Trilobites scuttling across the seafloor, early arthropods with armored shells, worm-like creatures digging through the sand. None of them were like us, yet they dominated the planet for tens of millions of years. Since then, Earth's stage has been cleared and reset many times. Continents drift as if they are slow rafts on a molten sea. They move a few centimeters each year, but over millions of years that tiny movement reshapes the entire planet. Around 335 million years ago, all the landmasses gathered into one supercontinent we call Pangaea. It stretched from pole to pole, a vast landscape where deserts, rivers, and forests stretched unbroken for thousands of kilometers. Dinosaurs would later roam its plains, but Pangaea did not last. Around 175 million years ago, it began to crack and drift apart. Oceans opened where valleys had been. Islands formed, grew, and vanished. Today's continents are only temporary arrangements in that long drift. The Atlantic Ocean, for example, is young. It opened less than 200 million years ago, as North America and Africa pulled away from each other. Before that, there was no ocean between them, only mountains and valleys that are now lost beneath the sea. Someday, millions of years from now, the Atlantic will likely close again as continents drift back together into a new supercontinent. The Earth is restless. It is always rewriting its map. Mountains, too, have their own cycles. The Himalayas, the tallest peaks on Earth today, began rising about 50 million years ago when India crashed into Asia. They are still rising now, centimeter by centimeter, even as wind and rain wear them down. Long before the Himalayas, other mountain chains rose higher than Everest, only to crumble back into plains. The Appalachian Mountains in North America, now rounded and green, were once taller than the Himalayas. Time reduced them to gentle slopes, erasing the drama of their peaks. Even oceans disappear. The Tethys Ocean once lay between Africa and Eurasia, filled with coral reefs and marine life. It is gone now, closed as continents press together. The Mediterranean Sea is one of its last remnants. Millions of years from now, even the Mediterranean may vanish, folded into new mountains or drained into desert basins. Deep time is not just long, it is active. It is a story of constant change, of creation and destruction. Nothing on Earth's surface is permanent. Rivers carve valleys, then shift and abandon them. Deserts spread and then retreat. Glaciers grow thick enough to cover continents, then melt away, leaving behind scars of rock and sand. The Sahara Desert, which feels eternal to us, was once green, dotted with lakes and grasslands where hippos and crocodiles lived. That was only a few thousand years ago. Go back further, and the Sahara has flipped between desert and savanna many times. What looks permanent in human eyes is only temporary in geological terms. Think of the impact of asteroids. 66 million years ago, a space rock struck near what is now Chicxulub in Mexico. The explosion ended the age of dinosaurs. Fires burned across continents. Ash and dust blocked sunlight for years. Temperatures plummeted. 3/4 of all species died. Yet from that destruction came a new age. Mammals, once small and hidden in shadows, began to rise. Without that asteroid, humans might never have existed. This is deep time, a world where catastrophes and cycles erase, reset, and create anew. In such a scale, even the greatest civilizations are fragile. Our species, Homo sapiens, has been here for only about 300,000 years. Civilization, cities, writing, organized states, for about 10,000 years. Compare that to 160 million years of dinosaurs, or 3 billion years of microbes. In the timeline of Earth, we are new arrivals, barely introduced. Understanding this is unsettling. It means that our history is not the grand center of Earth's story, but a short chapter at the end of a very long book. It means that what feels permanent, our cities, our borders, our ideas, is temporary. Just as mountains rise and fall, just as oceans open and close, civilizations too can be erased. To see this more clearly, imagine standing on the shore of the Atlantic today. Look at the waves rolling in. Beneath your feet lies ocean crust that is no more than 200 million years old. If you could peel back the water and see the seafloor, you would find ridges where magma rises, creating new crust, and trenches where old crust sinks back into the mantle. The floor of the Atlantic is younger than the dinosaurs. Someday, long after us, it will be gone. Or picture walking across the Appalachian Mountains. The hills are soft, green, and gentle. They feel ancient, and in a way they are. But they are also the ruins of something greater. Once, more than 400 million years ago, they were mountains higher than Everest, born when continents collided. Wind, water, and time wore them down. Now they are whispers of what they once were. If entire mountains can vanish, what chance does a city have? Deep time humbles us. It stretches our imagination to its limit. When you think in millions of years, human achievements seem delicate. A skyscraper, no matter how strong, is fragile compared to the slow power of geology. A civilization, no matter how advanced, is brief compared to the endless cycles of Earth. And yet, this is the scale we must think in if we are to ask whether we are the first. Because civilizations, if they ever rose before, would have lived and vanished in these vast stretches of time. Their traces, if any remain, would be buried in the same deep layers that record the drifting of continents and the opening of oceans. The Earth does not pause. It does not keep still. Its face is always shifting, always erasing, always writing new lines over the old. And within that restless motion, our story is only one of many. The Earth has an extraordinary talent, one so powerful that it is easy to forget. It knows how to erase. Slowly, silently, patiently, it removes the marks of what came before. No matter how vast, how strong, or how enduring something may seem, given enough time, the Earth will take it back. This ability is not malicious, it is not even intentional. It is simply the nature of a restless planet that is always moving, always reshaping itself, always turning old into new. We often imagine landscapes as permanent. Mountains feel eternal, rivers appear unchanging, deserts seem endless, yet nothing on the surface of the Earth truly lasts. What looks still to us is always in motion when viewed on geological scales. Rocks are lifted, folded, cracked, and ground down. Oceans rise, retreat, and vanish. Even continents are carried on slow currents of molten rock beneath our feet. The result is that almost everything, from the smallest artifact to the largest mountain chain, is temporary. Let's begin with erosion. Erosion is the quiet dismantling of the world around us, carried out by wind, water, and ice. To us, it happens so slowly that we rarely notice. A cliff seems solid for centuries, until one day it collapses. A river appears fixed in its course, but over time it meanders, carving new paths and abandoning old ones. Rain wears down stone, grain by grain. Frost cracks boulders apart as water seeps in, freezes, and expands. Roots split pavement. Sand, carried by wind, polishes rock like sandpaper. Think about the Grand Canyon. It is nearly 450 kilometers long, up to 29 kilometers wide, and more than 1.5 kilometers deep. To stand on its rim is to see what erosion can do when given time. For millions of years, the Colorado River has carved through layers of rock, cutting deeper and deeper, exposing nearly 2 billion years of Earth's history in its walls. What feels eternal is in fact the product of slow destruction. The canyon is both a creation and an erasure. It reveals history by removing it. Now, imagine how erosion treats human works. A building abandoned to rain and wind will crumble within centuries. Even stone monuments are not immune. Look at the statues of ancient empires. Weathered faces, missing limbs, inscriptions faded until they are almost unreadable. These changes happen in only a few thousand years. Multiply that by millions and nothing recognizable survives. But erosion is only the surface of Earth's erasing power. Beneath our feet lies tectonics, the great, slow movement of the planet's outer shell. The Earth's crust is divided into plates that float on the mantle below. They move only a few centimeters each year, but that tiny motion reshapes the entire globe. Plates collide, grind past each other, or pull apart, creating earthquakes, mountains, and rift valleys. Over millions of years, they rearrange the continents completely. This movement is not gentle for what lies on the surface. When plates collide, rock is thrust upward into mountains, crushing whatever stood above. When they separate, valleys and oceans open, swallowing landscapes. When they grind past each other, they shatter stone and send shockwaves through the ground. What once was surface can be lifted high into mountain peaks or buried kilometers deep beneath new layers. And then there is subduction. At the edges of some plates, one slab of crust dives beneath another, sliding slowly into the mantle, where it melts and becomes part of the Earth's interior again. This process recycles the ocean floor. Every piece of crust beneath the oceans today is younger than 200 million years. Older crust has already been swallowed. Compare that to the age of the Earth, 4.5 billion years, and you see how little of the ocean's past survives. Any trace of a civilization that lived on a coastline hundreds of millions of years ago would have been dragged down, melted, and erased completely. The continents survive longer than the ocean floor, but they too are not immune. They are cracked and folded, worn down and rebuilt. Rocks that once lay deep underground are pushed upward to form mountains. Mountains are ground down into sand, carried by rivers to the sea, and compressed again into stone. Every cycle mixes, buries, and destroys. In this endless recycling, the surface of the Earth is always young, no matter how old the planet is. This explains why fossils are rare. For a creature to be preserved, it must die in just the right place, buried quickly in mud, sand, or ash. It must escape scavengers, bacteria, and decay. Minerals must seep in, replacing bone and tissue with stone. Even then, the fossil must survive erosion, tectonics, and burial for millions of years before being found. Out of the countless creatures that have lived, only a fraction left fossils. Most disappeared completely, their existence remembered only in DNA carried forward into future species. Consider the dinosaurs. They ruled the land for 160 million years, far longer than humans have existed. Billions upon billions of them lived, from small feathered hunters to giants like Argentinosaurus, which may have weighed more than 70 tons. Yet we know them mostly from fragments. A tooth here, a claw there, a few complete skeletons by rare luck. For every fossil we have, millions of dinosaurs left no trace. Entire species may have come and gone without leaving a single bone behind. Artifacts are even less likely to survive. Tools, pottery, or buildings made of organic materials decay quickly. Even metals corrode and break down over time. Gold might endure, but only if it is not melted, eroded, or buried beyond reach. Iron rusts, bronze weathers, and wood vanishes in decades. If an ancient civilization had existed millions of years ago, especially one that built mostly with perishable materials, we would expect almost nothing to remain. Earth's ability to erase also shows in events we can still see. Look at glaciers. During the last ice age, massive sheets of ice, kilometers thick, covered much of North America, Europe, and Asia. As they moved, they scraped the land beneath, grinding down mountains, scooping out valleys, and leaving behind fields of boulders and gravel. When the ice melted, it left lakes, like the Great Lakes of North America, carved directly by glaciers. Anything that stood in their way, forests, rivers, even entire landscapes, was wiped clean. Volcanoes tell the same story. When Mount Vesuvius erupted in 79 CE, it buried Pompeii in ash within hours. Lives, buildings, art, all hidden until rediscovery nearly 2,000 years later. That may sound like preservation, but in most eruptions the opposite happens. Entire landscapes are obliterated. Lava buries villages, ash collapses roofs, fire consumes forests. In deep time, volcanic activity not only reshapes the surface, but often erases it completely. Earthquakes can do the same. In 1556, a single earthquake in China killed hundreds of thousands of people and leveled entire towns. Multiply that destruction by millions of years of tectonic activity, and the permanence of any structure seems laughably small. Even the air and water are erasers. Oxygen corrodes metals. Rain dissolves stone. Salt water eats away at everything it touches. Think of shipwrecks. Vessels that sank only a few centuries ago are now rusted skeletons covered in coral and sea life. Wooden ships vanish even faster, leaving behind little more than ballast stones and scattered cargo. On land, wooden houses vanish within centuries unless they are carefully maintained. Stone temples become ruins. Metal tools rust into dust. Time is a patient but relentless editor. Sometimes, the earth erases so thoroughly that it feels as if nothing was ever there. Entire rivers vanish into deserts, leaving behind dry channels called wadis. Lakes fill with sediment until they are meadows. Forests become coal, pressed into rock by heat and weight. The living world is recycled into the earth's memory, stored not as intact records but as fragments, impressions, or chemical traces. This is why so much of the past is invisible. We marvel at the fossils we find, but we forget how much has been lost. The record we study is a patchwork, a handful of surviving scraps from a book that once contained countless chapters. The earth is not trying to hide them. It is simply doing what it always does, turning the old into the new. If we imagine an earlier civilization, one that rose millions of years ago, we must remember how slim the chances of discovery are. Unless they left behind vast stone monuments in just the right places, their traces would have been worn away, buried, subducted, or dissolved. Even if a few fragments survived, they might be mistaken for natural formations or dismissed as anomalies. This realization is both humbling and unsettling. It reminds us that what we see today, fossils in museums, ruins in deserts, artifacts in the ground, are not the full story, but the rare survivors. The vast majority of life, of history, of possible civilizations has been erased. And yet within this erasure there is also creation. The same forces that destroy also build. Erosion carves canyons, but also creates fertile soil. Tectonics shatter rocks, but also raise mountains. Subduction erases seafloor, but also fuels volcanoes that create new land. In this endless cycle, the earth does not simply wipe clean, it rewrites. To explore whether we are the first civilization, we must look not only at what is preserved, but also at what is missing. The gaps in the record may hold as much meaning as the fossils and ruins we admire, because what is gone tells its own story. A story of a planet in constant motion, a world that remembers very little and forgets almost everything. And it is within this forgetting that the greatest mystery lies. If others came before us, the earth may have already turned their memory into dust, stone, and silence. When scientists talk about the possibility of a civilization before ours, they do not picture statues on the seafloor or skyscrapers under the ice. They picture chemistry. They picture the quiet fingerprints that industry leaves behind, traces written not in stone monuments but in the composition of the Earth itself. This is the heart of what is known as the Silurian Hypothesis. The name sounds unusual, almost playful. It comes from a British science fiction series in which intelligent reptilian beings called Silurians once ruled the Earth before retreating underground. Two scientists, Gavin Schmidt, a climatologist at NASA, and Adam Frank, an astrophysicist at the University of Rochester, borrowed the name in 2018 for their paper. They were not proposing that ancient reptiles built cities. Instead, they used the name as a tongue-in-cheek way to frame a serious scientific question. If an industrial civilization had existed on Earth millions of years ago, would we be able to detect it today? The question matters because of deep time. As we've seen, the surface of the Earth is constantly erased and rewritten. Buildings vanish, bones dissolve, and even entire continents shift. If a civilization lived 10 million years ago, the chance of us finding its pottery, tools, or monuments is close to zero. But Schmidt and Frank wondered, what about its impact? Could the traces of industry, agriculture, or energy use survive in the geologic record? Their idea was not to prove that such a civilization existed, but to test the limits of science. If our own civilization were to disappear, what signs would we leave for future geologists millions of years from now? And could those same kinds of signs be hidden in the rocks we study today? To answer this, they looked not at ruins, but at markers. In geology, markers are measurable changes preserved in sediments, ice cores, or rock layers. They can tell stories long after direct evidence is gone. For example, thin layers of iridium-rich clay found around the world mark the asteroid impact that ended the age of dinosaurs 66 million years ago. Nobody saw that impact, but the layer of metal it spread across the Earth is a signature, a clear fingerprint of the event. So what fingerprints would civilization leave? Schmidt and Frank listed several possibilities. The first is carbon. Our industrial world burns enormous amounts of fossil fuels, releasing carbon dioxide into the air. This changes the ratio of carbon isotopes in the atmosphere. Isotopes are forms of the same element with different weights. Plants and fuels made from them have distinct isotope signatures. When we burn coal, oil, and gas, we release carbon that has been locked away for millions of years. This shifts the balance of isotopes in the air and oceans. Future geologists could detect this shift in the rocks and sediments, just as we detect past changes in ancient layers. The second marker is plastics. Plastics are everywhere, in packaging, clothing, cars, electronics, even in the dust floating in the air. They are synthetic, meaning they do not occur naturally. Already plastic particles are sinking into ocean sediments, mixing with sand and shells. Scientists have coined a term for rock-like materials that contain plastic fused with natural minerals, plastic glomerates. If preserved, these could be strange fossils of our age, clear signs that something unusual was happening on Earth. Then there are fertilizers. Modern agriculture uses nitrogen-based fertilizers in huge quantities. This alters the balance of nitrogen in soils and waterways, which in turn affects the chemical record. Over time, layers of sediment may show a distinct fingerprint of altered nitrogen cycles, pointing to large-scale human activity. Radioactive isotopes provide another clear signal. Nuclear tests in the mid-20th century spread isotopes like plutonium-244 across the globe. These isotopes do not occur naturally in measurable amounts and have half-lives long enough to survive for millions of years. If geologists in a distant future were to drill into sediments from our time, they would likely find these isotopes as unmistakable evidence of technological activity. Concrete and metals also matter. Concrete is now the most widely used human-made material on Earth. It blankets our cities, roads, and bridges. When it weathers and breaks down, its chemical composition mixes into soils and sediments. Metals like aluminum and rare earth elements, mined and refined in massive quantities, could also leave unusual concentrations in geological layers. All of these traces add up to what scientists call the Anthropocene, a proposed new epoch in Earth's history defined by human impact. Whether or not geologists officially adopt the term, the evidence is there. In a few million years, If someone else studies the rocks of our age, they would likely see a sharp and unusual pattern, a sudden spike in carbon, nitrogen, plastic, and radioactive isotopes, a thin but unmistakable chapter in the planet's book. This is what Schmidt and Frank focused on, the markers that survive even when the structures do not. If an earlier civilization existed, it too might have left such markers. Not the same ones, perhaps. They may not have used plastics or nuclear energy, but other industrial byproducts that altered the chemistry of the planet. If so, those changes might still be detectable today, buried in layers of rock we have already studied, but interpreted as natural. The unsettling part of this idea is not that we have found such markers. We have not. The unsettling part is that we may not know how to look for them. If another civilization had its own form of industry, it might have used energy sources or processes that left different traces. They could have changed the climate in ways we cannot easily distinguish from natural fluctuations. Their markers could be subtle, strange, or hidden among the noise of natural cycles. To see why this is difficult, think of how patchy the geological record is. Some layers are well preserved, others are missing entirely. Erosion, tectonics, and subduction remove vast portions of Earth's history. What remains is a scattered archive full of gaps. Detecting a brief industrial phase that happened tens of millions of years ago would be like reading a book with most of its pages torn out. Even if clues were left behind, we might never see them. Still, the exercise has value. By asking how to detect a past civilization, scientists sharpen their tools for studying our own. It forces them to think carefully about what survives, what doesn't, and what signals to look for. It also reminds us that our own age is not invisible. We are writing ourselves into the rocks right now. Imagine a geologist millions of years from now digging into a cliff. They split open a layer and find an abrupt shift in chemistry, a sudden rise in carbon isotopes, traces of plastic polymers embedded in stone, radioactive isotopes not seen in earlier layers. To them, it might look as strange as the iridium layer looks to us, a sign that something dramatic happened. They may not know what we were, what languages we spoke, what stories we told, but they would know this: at some point, there was a civilization here. This comparison between the hypothetical past and our present is the power of the Silurian Hypothesis. It is not a claim that we are not the first. It is a reminder that if others came before, their traces would likely be subtle, chemical, rather than structural, and difficult to distinguish. And it is also a mirror, showing us the marks we are leaving behind. Think again about the Anthropocene. Plastic particles now reach the deepest parts of the ocean. Microplastics fall with the rain. Tiny fragments drift through the air, carried across continents. These are not fleeting pollutants. They are materials that will persist for thousands, perhaps millions of years. Sediments are quietly recording them in layers that may one day harden into stone. Nuclear isotopes, too, are long-lived. Some have half-lives of tens of thousands of years. Even after civilizations vanish, these isotopes will linger, buried in layers, waiting to be read. Fertilizer drill nitrogen spikes may also survive, marking a sharp change in the natural cycle. Each of these is like a signature, a chemical note added to the Earth's memory. This raises an eerie possibility. What if we are already looking at such markers from the distant past without realizing it? What if some of the chemical anomalies we explain as natural, sudden warming events, shifts in carbon or oxygen levels, were in fact the fingerprints of another civilization? At present, we assume they were caused by volcanic eruptions, asteroid impacts, or natural climate cycles, but could some of them be echoes of a lost world? Scientists remain cautious. Natural explanations are always the first choice, and with good reason. Volcanoes and impacts have left clear marks throughout history, but the Silurian hypothesis invites us to keep our minds open, to recognize that absence of direct evidence does not prove non-existence. The Earth forgets too much, too easily. What matters most is perspective. The hypothesis is not only about the past, it is also about the future. It asks us to see our own civilization in geological time. To understand that we too will vanish from the surface, leaving only faint traces in stone. It is a humbling thought, but also a unifying one. It connects us to the deep rhythms of the planet. When you step back far enough, every civilization, no matter how grand, is temporary. Their temples, their roads, their technologies, all are erased. What endures are the quiet fingerprints, the subtle changes recorded in the Earth's chemistry. That is what the Silurian Hypothesis teaches us. And from here, our journey moves outward, beyond science papers and markers in stone, toward the human imagination itself. Because even as science searches for traces, our stories, myths, and legends have long whispered of lost worlds. Perhaps not proof, but echoes. Perhaps not history, but memory. And it is to those myths and echoes that we now turn. Long before scientists proposed hypotheses about vanished civilizations, humans told stories. Around fires, in temples, in songs passed down for centuries, people spoke of worlds that had once been great but were now gone. Some of these stories were warnings, others were allegories, and some may have carried fragments of memories so old that they blurred into myth. Today, when we hear names like Atlantis, Lemuria, or Mu, they sound like legends. Yet they also reveal something about us, the deep human intuition that what we see is not all that has ever been. Let us begin with Atlantis, the most famous of all. The story comes from the Greek philosopher Plato, writing in the 4th century BCE. He described Atlantis as a powerful island civilization beyond the Pillars of Hercules, which we now call the Strait of Gibraltar. According to Plato, Atlantis was wealthy and technologically advanced, but it became corrupt and greedy. The gods, displeased, punished it with earthquakes and floods. In a single day and night, Atlantis sank into the sea. For centuries, people have searched for Atlantis in almost every corner of the globe. Some place it in the Mediterranean, others in the Caribbean, others still beneath Antarctic ice. None of these locations have produced evidence. Most historians believe Plato invented Atlantis as an allegory, a moral tale about hubris and downfall, not a historical record. Yet the power of the story has endured for more than 2,000 years. Why? Perhaps because it speaks to something deeper than fact, the fear that great civilizations, no matter how strong, can fall and be forgotten. Lemuria and Mu are younger myths, born in the 19th century. At that time, scientists were puzzled by the distribution of species, particularly lemurs in Madagascar and India, but not in Africa or the Middle East. Some suggested a lost continent once connected these lands. They named it Lemuria. Later, spiritual writers expanded the idea, imagining an advanced civilization that had once flourished there before sinking beneath the waves. Around the same time, another writer, Augustus Le Plongeon, claimed that inscriptions in Central America spoke of an ancient lost land he called Mu, supposedly in the Pacific. Neither Lemuria nor Mu ever had geological evidence behind them, but the names caught the imagination. They became symbols of hidden worlds, reminders that the Earth might hold stories older than we know. Even though these myths are not science, they reveal a pattern. Across cultures, stories of sunken lands, vanished kingdoms, or forgotten ages appear again and again. Flood myths are nearly universal, from Mesopotamia's Epic of Gilgamesh to the biblical Noah, to oral traditions among indigenous peoples across the globe. These myths may not describe literal civilizations swallowed whole, but they may preserve memories of real events. Rising seas, sudden floods, or shifting coastlines experienced by ancestors thousands of years ago. Modern discoveries have shown that sometimes myth and memory align with geology and archaeology. Take Doggerland, for example. Today, the North Sea stretches between Britain and mainland, but less than 12,000 years ago, much of that sea was dry land. Doggerland was a vast plain of rivers, lakes, and forests where people lived, hunted, and built their lives. As the Ice Age ended and glaciers melted, sea levels rose. The land was gradually submerged until only islands remained, and eventually even those vanished beneath the waves. For centuries, Doggerland was unknown, but fishermen in the North Sea began pulling up ancient bones and tools in their nets. Archaeologists investigated and sonar mapping confirmed it. A lost landscape, once home to humans, now drowned beneath the ocean. Another example is Göbekli Tepe in modern-day Turkey. Discovered in the 1990s, it rewrote much of what we thought we knew about early civilization. For generations, archaeologists believed that complex societies, with monumental architecture, organized religion, and large gatherings, only emerged after the invention of farming. But Göbekli Tepe is different. It is more than 11,000 years old, built long before cities or agriculture. Massive stone pillars, carved with animals, arranged in circles, a temple complex from a time we thought humans were still only simple hunter-gatherers. Its discovery forced us to reconsider our timeline. Civilization, or at least the capacity for organized culture, began earlier than we thought. Stories like Atlantis may be myths, but places like Doggerland and Göbekli Tepe show that human memory is not always wrong to imagine lost worlds. The difference is that myths frame them as moral tales or grand civilizations, while science uncovers them as landscapes and settlements shaped by climate and time. Sometimes the two perspectives overlap, echoing one another across millennia. This overlap is important. Myths are not peer-reviewed evidence, but they are clues to how humans experience change. When seas rise, when earthquakes strike, when landscapes shift, people remember. They may not write scientific reports, but they tell stories. Those stories, told again and again, stretch across generations, eventually becoming myth. To us, they sound like fantasy, but to the people who told them first, they were memory, transformed into story, so that it would not be forgotten. Think of how myths and science intersect in another example, the eruption of Thera, also called Santorini, in the Aegean Sea. Around 1600 BCE, the island exploded in one of the largest volcanic eruptions in recorded history. It destroyed settlements, sent tsunamis across the region, and covered the skies with ash. Some historians believe this disaster may lie behind parts of the Atlantis myth or other flood stories in Greek tradition. Here, a real event left echoes in both geology and myth, blending into legend over time. In this way, myths serve as cultural fossils. They may not preserve details with accuracy, but they capture impressions, the emotional truth of loss, the memory of landscapes swallowed, the awareness that nothing lasts forever. Just as physical fossils give us glimpses of life that once was, myths give us glimpses of how ancient peoples experienced their world and its changes. For our question whether we are the first civilization, myths do not provide evidence, but they do remind us of something essential. Humans are storytellers. When we see the world change in ways that frighten or confuse us, we tell stories to make sense of it. Some of those stories survive thousands of years, outlasting the events themselves. And so, the myths of Atlantis, Lemuria, and Mu may not describe literal civilizations, but they reveal our enduring sense that there may be chapters of history missing, buried beneath water or time. And the real discoveries of Doggerland and Göbekli Tepe prove that the Earth does indeed hold forgotten worlds, sometimes hidden in plain sight, waiting for science to rediscover them. From here, the path leads naturally to the oceans themselves. For if myths often speak of sunken lands, and if science confirms that coastlines and continents have drowned and shifted, then the sea is the largest keeper of secrets. 70% of our planet is covered by water, most of it unexplored. And beneath those waves may lie landscapes, artifacts, and stories we have yet to uncover. When we think of the Earth, we often picture land, continents, mountains, deserts, forests. Yet most of our planet is not land at all. More than 70% of the Earth is covered by ocean. These waters hold most of the biosphere, most of the heat, most of the cycles that shape climate and weather. They are so vast that even today, with satellites circling the globe and ships crisscrossing every sea, most of the ocean floor remains unmapped. In truth, we know the surface of the Moon and Mars in greater detail than we know the bottom of our own seas. This imbalance is striking. Our history books are full of stories of empires, kings, wars, and cities on land, but the oceans are quieter. They keep their secrets well. And in those hidden depths, entire landscapes and perhaps chapters of human and planetary history may lie drowned and forgotten. The ocean is not a static body. It is restless, reshaped by tides, currents, storms, and geology. The seafloor is constantly renewed. Unlike the continents, which can endure for billions of years, every piece of oceanic crust is temporary. It forms at mid-ocean ridges, where molten rock wells up from below, and it disappears at subduction zones, where plates of crust dive back into the mantle and melt. This cycle means that no part of the ocean floor is older than about 200 million years. Compared to the 4.5 billion year age of the Earth, that is young. Think of what this means. If a civilization ever built something on the ocean floor more than 200 million years ago, it would be gone now, erased not just by erosion, but by the recycling of the crust itself. Swallowed, melted, and remade as new rock. Even on shorter scales, the ocean is not kind to memory. Salt water corrodes metals, waves smash stone, sediment buries remains under layers of mud and sand, but not everything disappears. Some things survive in the shallows, in coastal zones, or on continental shelves, the submerged edges of continents that stretch far out under the water. These shelves were once dry land during the ice ages, when sea levels were lower. As glaciers melted, the seas rose, drowning coastlines, valleys, and plains where humans once lived. Today, those ancient landscapes lie hidden beneath shallow seas, waiting in silence. Doggerland is one such place. We touched on it before, but it deserves closer attention here, for it shows how much can be lost to the sea. 12,000 years ago, at the end of the last ice age, sea levels were over 100 meters lower than today. The North Sea was not a sea at all, but a broad plain connecting Britain to Europe. Rivers wound through forests and marshes. People hunted, gathered, and fished there. They built camps and moved with the seasons. As the climate warmed, glaciers melted and seas rose. Slowly, Doggerland shrank. Hills became islands, marshes turned to bays. By around 6,000 years ago, the last of the land was gone, swallowed by the sea. For centuries, no one knew it had ever existed. Then, fishermen began pulling up bones of mammoths, reindeer, and even human tools from the seabed. Sonar mapping revealed the outlines of ancient rivers and lakes still etched into the seafloor. Doggerland was rediscovered, not as myth, but as memory, preserved beneath the waves. Doggerland is not unique. Around the world, coastlines have shifted dramatically. Off the coast of India lies a place called the Gulf of Cambat, where sonar surveys have suggested ancient structures may rest beneath the water. Near Japan, the Yonaguni Monument, a series of submerged terraces and steps, has sparked debate. Are they natural formations or human-made? In the Black Sea, scientists have found traces of ancient shorelines far below the current surface, evidence of rapid flooding thousands of years ago. In the Caribbean and Mediterranean, divers have found roads, walls, and harbors long drowned by rising seas. Each of these discoveries is a reminder that oceans are not just barriers or blank spaces on maps. They are archives. They preserve entire landscapes beneath their waves, places once walked by humans or other creatures, now hidden in darkness. The erasing power of the sea comes in many forms. One is subduction, as we've mentioned. Picture the Pacific Ocean, ringed by trenches where plates sink into the mantle. The Mariana Trench, the Peru-Chile Trench, the Japan Trench. Here, entire slabs of ocean floor, kilometers thick, slide downward over millions of years. Whatever rests on that crust is carried with it, destroyed in heat and pressure deep within the earth. This recycling makes the ocean young. It ensures that even the grandest structures built upon its floor would not survive long in geological terms. Another is sedimentation. Rivers carry silt, sand, and mud into the sea, where it settles in layers. Over time, these layers bury anything left on the sea floor. Shipwrecks vanish beneath them. Coastal towns lost to storms disappear under meters of sand. In tens of thousands of years, these sediments harden into rock, hiding whatever they covered. Storms and tsunamis also reshape coasts. In 2004, The Indian Ocean tsunami inundated entire villages, sweeping away buildings, roads, and people in hours. Multiply such events across millennia, and the erasing force of water becomes clear. Even great cities, if struck by repeated floods, would vanish beneath the tides. And yet the ocean also preserves. In its cold, oxygen-poor depths, wooden ships can survive for centuries, even millennia. The Black Sea is especially famous for this, where shipwrecks thousands of years old lie intact on the seafloor. In some cases, cargo still rests inside, untouched since the day the vessel sank. The same waters that destroy can also protect, wrapping their secrets in silence. When we think of lost civilizations, we often imagine deserts, jungles, or mountains swallowing them. But the ocean may hold more than all of these combined. Because sea levels have risen and fallen so often in Earth's history, countless coastlines, settlements, and perhaps even entire cultures now lie underwater. Each ice age lowered the seas, exposing vast areas of land. Each warming period raised them again, drowning those lands. What we see as permanent coastlines today are only temporary, waiting for the next shift. Consider the Sunda Shelf in Southeast Asia. During the last ice age, it was not a scattering of islands, but a continuous landmass connecting Malaysia, Indonesia, and the Philippines. People lived there, migrating across plains that are now beneath the South China Sea. When the waters rose, those plains were lost. Similarly, the Bering Land Bridge once connected Siberia and Alaska, allowing humans and animals to cross. Today it lies under the Bering Strait. These drowned landscapes are reminders that much of human prehistory is hidden below the sea. The mystery deepens when we extend this idea back beyond human time. If coastlines could erase entire cultures within a few thousand years, what might have been lost in millions? Whole ecosystems, strange species, maybe even something more complex. The ocean does not keep diaries. It takes, it buries, and it changes. And yet, as silent as it is, the ocean is not impenetrable. Technology is slowly revealing its secrets. Sonar mapping, remotely operated vehicles, and submersibles allow us to glimpse landscapes hidden for millennia. We can see riverbeds carved into the seafloor, ancient shorelines, and the traces of settlements that once thrived, where now only fish swim. Each discovery reminds us that the sea is not empty. It is a vast archive of forgotten worlds. This brings us back to our central question. If there had been civilizations before us, could their remains lie beneath the ocean, drowned and forgotten? We cannot know for sure, but we do know this. The ocean covers most of the Earth, and we have explored only a fraction of it. Its depths are dark, its floor is young, and its shelves hide landscapes that were once alive. To search for the past, we must look not only to deserts and mountains, but also to the waves. And as we leave the ocean behind for now, we step into another layer of mystery. The strange finds and anomalies that sometimes surface on land. Objects and stories that do not fit neatly into our timelines. Are they errors, misunderstandings, or glimpses of something more? It is there, in the anomalies, that our journey continues. If the Earth could speak, it would remind us that nothing is truly permanent. Mountains crumble, rivers carve new paths, forests rise and fall, and even the continents drift apart and collide again. What feels solid in a human lifetime is only a passing sketch on the vast canvas of geological time. Against this shifting backdrop, a question naturally arises. Of all the things humanity has built, what will truly last? The answer begins in places we can still walk through today. An abandoned building, left alone for a few decades, already shows nature's persistence. Windows crack, roofs sag, roots snake through foundations. A house, empty for half a century, often looks more like a ruin than a shelter. Now imagine entire cities abandoned. Pripyat near Chernobyl offers one of the clearest examples. Once a bustling modern settlement, it has been empty since 1986. Less than 40 years later, its streets are lined with birch trees, wild animals roam freely, and concrete structures are peeling and collapsing. What seemed permanent was only briefly resistant. The jungle temples of Cambodia tell the same story on a longer scale. Angkor Wat, once the center of a great empire, was swallowed by vines and trees until it seemed almost mythical when rediscovered. Petra, the rose-red city of Jordan, was hidden by sandstorms and desert winds, its carved facades fading into cliffs. Machu Picchu, high in the Andes, slipped quietly back into cloud forests until the 20th century, when the world's gaze found it again. In every case, even stone structures considered monumental were steadily reclaimed by weather and time. Yet stone, as fragile as it may appear, is still among the most enduring materials we use. To understand what lasts, we must look closely at each of the materials that make up our civilizations. Wood, so common in homes and furniture, disappears quickly. Unless sealed in deserts, frozen tundra, or waterlogged bogs, it decays within decades. Archaeologists have uncovered wooden artifacts thousands of years old, but always from unusual conditions. Timbers preserved in peat bogs or beams encased in volcanic ash. In ordinary soil, wood becomes soil itself, vanishing silently. Metals feel stronger. Bronze and gold can survive for millennia, and sometimes longer if hidden from moisture. But most metals are surprisingly fragile in the long run. Iron rusts quickly, eaten by oxygen and water. Aluminum oxidizes to a dull powder. Copper gains its green patina, then slowly erodes away. A modern bridge or skyscraper, dominated by steel, might endure for centuries, but 10,000 years later it would exist only as faint streaks of mineral in the ground. Concrete is a curious story. Our modern world is paved and built with it, from dams to highways, and yet many forms of modern concrete are expected to last only a few hundred years without upkeep. Cracks spread, water seeps in, freeze-thaw cycles break it apart. Ancient Roman concrete, however, has survived for 2,000 years, in some cases even strengthening with time. The secret lay in their use of volcanic ash, which reacted with seawater to produce new minerals that reinforced the material. Whether our own formulations will last as long is uncertain. Glass is another surprise. Fragile in the hand, it can outlast steel in the ground. Volcanic glass, obsidian, has survived for millions of years. Human-made glass often weathers, turning cloudy or breaking down, but in dry environments, it can remain intact for astonishing periods. A glass bottle buried in desert sand may survive longer than a towering skyscraper. Ceramics, however, are the true champions of endurance. Fired clay resists weather and time better than almost anything we make. Pottery shards litter sites of ancient villages, outlasting wood, metal, and cloth. Archaeologists often find ceramics where everything else has vanished. In millions of years, fragments of our dishes, tiles, and bricks may still remain, tiny shards telling of human presence long after skyscrapers have been erased. And then there is plastic, the strange paradox of modern times. Created to be disposable, it may become one of the most enduring markers of our age. Most plastics fragment under sunlight and pressure, breaking into particles too small to see. These microplastics drift into rivers, seas, and soils, settling into layers of sediment. Over time, they may fossilize into plastiglomerates, strange new stones made from plastic fused with sand, shells, and lava. In deep time, these odd materials could be among the clearest signatures that our civilization once existed. Radioactive isotopes are another indelible trace. Formed in nuclear tests and accidents, some decay slowly over tens of thousands or millions of years. Locked in sediments, they create a chemical timestamp, a unique signal that something unusual happened in this era. Even if no ruins remain, the isotopes will whisper of our presence to anyone or anything that digs deep enough. To grasp the fragility of our world, it helps to stretch our vision across time. A century after abandonment, our cities would still stand, though they would already be cloaked in green. Bridges would be rusting, books long decayed, and forests reclaiming the streets. After 1,000 years, the picture is quieter. Only stone monuments and scattered ceramics would be recognizable. Metals would have crumbled. Concrete would be fractured and buried. 10,000 years into the future, almost everything we know would have disappeared. Perhaps a few massive stone structures would resist, softened and worn, their original shapes difficult to discern. Pottery fragments would lie scattered like whispers of domestic life. Plastics, broken into invisible fragments, would be buried in mud and sand, beginning the slow transformation into new kinds of rock. And after 1,000,000 years, our world would be gone. Rivers would have redrawn landscapes. Mountains would have risen and fallen. Entire coastlines would have shifted. The monuments we now prize would be dust or deeply buried. What remained would not be recognizable structures, but signals, layers of sediment rich in carbon from our burning of fossil fuels, isotopes marking our nuclear age, tiny stones of fused plastic telling of an era when humans transformed oil into waste. These would be the faint but undeniable markers of our existence. Still, the Earth sometimes surprises us with extraordinary preservation. In Siberian permafrost, mammoths remain frozen with fur and flesh intact. In tar pits like La Brea, bones of saber-toothed cats have endured for tens of thousands of years, trapped in asphalt. In deserts, mummies have survived with hair and skin. In amber, the hardened resin of trees, insects have been preserved for more than 100 million years, their wings and eyes still visible. These rare cases remind us that under the right conditions, even delicate things can endure far beyond expectation. Perhaps some of our own creations, sealed in mud, frozen in ice, or buried under ash, will persist longer than we imagine. Yet the larger truth is humbling. Civilizations, no matter how advanced, are fragile against the scales of time. What feels permanent to us is only temporary to the Earth. The true legacy of humanity will not be our tallest buildings or most intricate machines, but the quiet signatures written into stone and soil. The chemical shadows, the scattered shards, the subtle anomalies that whisper, here, for a brief moment, there was something different. And once we accept how little of us may endure, another question rises. If traces of our civilization will be so faint, then how would we ever recognize the traces of others who may have come before? What if intelligence took forms that left no monuments, no cities, no artifacts that resemble our own? What if it was expressed in ways almost invisible to us, hidden in patterns we have not yet learned to see? When we think about the legacy of our civilization, it is tempting to imagine monuments lasting forever. Stone pyramids, steel towers, highways stretching across continents, these seem unshakable against the passage of time. But time in geological terms is merciless. A century is a blink, 1,000 years is still nothing, and millions of years, the scale we must consider when asking what truly survives, is enough to erase almost everything we know. To picture this, it helps to slow down and imagine the world around us vanishing step by step. Take a modern city, perhaps one you know well, filled with lights, traffic, voices, and towering buildings. Now remove the people. No maintenance crews, no repairs, no power grid. The transformation begins almost instantly. Within days, plants begin pushing through cracks in pavement. Within weeks, windows break, roofs leak, and animals move in. A place designed for humans begins to reshape itself for something else. After 100 years, the effect is startling. Forests creep into suburbs, roots shatter sidewalks, buildings sag as wood rots and metal rusts, books are gone, paper reduced to dust, plastics lie scattered, some brittle from sunlight, some buried in soil. Of the shining city, only skeletons remain, already fading. 1,000 years forward, and the picture is stranger still. The tallest buildings have collapsed. Concrete has fractured, covered by earth and vines. Metals, unless shielded, are mostly corroded into flakes. Only stone and ceramics keep their shape, though worn and scattered. Great monuments may still stand, but weathered and leaning, no longer recognizable as the proud symbols they once were. From above, the landscape no longer looks urban, it looks natural, dotted here and there with hints of what once was. 10,000 years, most traces of architecture are gone. A few massive stone structures survive, the way we still see remnants of temples from our own ancient past. Pottery shards scatter through soil, as they always seem to do, waiting for curious hands to find them. Plastics linger too, though not as bottles or bags, but as micro-fragments buried in sediments, mixed invisibly into sand and clay. If any descendants of today's life were to walk here, They might stumble upon something odd, but the city itself would be a memory erased. Stretch the clock further, to 1,000,000 years. By then, even mountains shift. Rivers cut new valleys. Entire landscapes are rearranged. Nothing of our buildings remains in recognizable form. What endures are not structures, but chemical whispers. Unusual isotopes, strange concentrations of metals, and fossil-like stones where molten plastic fused with rock. These are not monuments, but signatures, faint clues in the geological record that something unusual once lived here. Different materials tell this story in their own ways. Stone, shaped by hands into temples or statues, is the most likely to endure. The pyramids of Egypt or the statues of Easter Island show us that. Yet even stone crumbles. Wind, water, frost, and heat slowly break it down. Over thousands of years, carvings blur. Over millions, entire blocks turn back to sand. What seems eternal to us is temporary to the earth. Metal is less forgiving. Iron rusts, copper corrodes, aluminum oxidizes. Unless carefully protected, metals return to dust far faster than stone. Bronze statues may last for centuries, perhaps even millennia, but given enough time, they too dissolve. Gold is the exception, almost immune to corrosion. Small objects of gold may survive for tens of thousands of years, though scattered and buried. But gold is rare, a thin thread in the vast fabric of civilization. Concrete, the backbone of our cities, is strong in our lifetimes, but surprisingly fragile in deep time. Cracks allow water in, freezing and expanding until entire walls break apart. Without constant repair, concrete structures crumble in a matter of centuries. In 1,000 years, they are heaps of rubble. In 10,000, they are indistinguishable from natural stone. Our highways and skyscrapers, built as symbols of permanence, are among the first to fade when the caretakers are gone. Plastic tells a different story. It is a material almost unknown to nature, created in vast quantities by humans. It resists decay, yet sunlight, oxygen, and bacteria slowly break it into fragments. Over thousands of years, these fragments become smaller and smaller until they are microplastics, invisible to the eye but still present in soil, rivers, and oceans. In some places, plastic has even melted and fused with sand, forming plastiglomerates, hybrid rocks that could one day fossilize. Millions of years from now, these strange stones may be the clearest evidence that humans once existed. Nature gives us previews of this process in places we can see today. Chernobyl is one of the most striking. After the nuclear disaster of 1986, people left the surrounding area. What followed was not a lifeless wasteland, but a resurgence of wilderness. Trees grew through streets, animals returned, wolves, deer, even species thought to be gone. Buildings decayed, but the forest thrived. In just a few decades, the city of Pripyat transformed from a human settlement into a landscape reclaimed by nature. Other examples are older. Angkor Wat in Cambodia, once a grand temple complex, was swallowed by jungle when abandoned. Roots of massive trees split stone walls, wrapping monuments in living wood. In South America, ancient cities of the Maya and Inca lay hidden for centuries beneath forests until rediscovered. Even the deserts of the Middle East hide ruins beneath shifting sands. Everywhere nature waits, ready to reclaim what is left behind. What these examples show is that human presence is fragile without constant care. Buildings require repair, roads need resurfacing, monuments need preservation. Once that ends, nature begins its slow but certain work. In the short term, the signs are obvious: rusting metal, collapsing roofs, weeds in the pavement. In the long term, the signs are erased entirely, folded back into soil and stone. On the scale of millions of years, Earth is an efficient recycler. Plate tectonics drags the crust down into the mantle, melting rock and creating new surfaces. Oceans grind coastlines. Glaciers carve valleys. Wind levels mountains. Fossils themselves are rare because the process of preservation is so demanding. A creature must be buried quickly, protected from decay, and mineralized before it is destroyed. If that is true for bones, how much more so for buildings, tools, or records? And yet, traces do endure, not as ruins we might recognize, but as subtle clues. In sediment layers, unusual spikes of certain chemicals tell stories. The boundary marking the extinction of the dinosaurs, for example, is rich in iridium, a metal more common in asteroids than in Earth's crust. Future geologists, whether human or something else, might one day see in our layer the spread of plastics, the rise of carbon dioxide, or the scattering of radioactive isotopes from nuclear activity. To them, these would be signals of a moment when something unusual happened. This is what survival truly means for civilization, not shining towers or enduring texts, but patterns written into the Earth's skin. Our legacy will be fragments, chemical shifts, and strange stones. To imagine our monuments still standing after millions of years is to misunderstand the patience of the planet. Mountains rise and fall in less time. Oceans appear and disappear. Civilizations, even global ones, are ripples in that sea. Still, there is something humbling and even beautiful about this. To know that our presence may be reduced to a thin layer in the rock record is not a sign of failure, but a reminder of scale. We are part of a much larger story, one in which nothing resists time forever. What survives is not the detail, but the trace, not the building, but the mark it left behind. Civilization is a word that tends to borrow our shape. Say it out loud and most people picture skylines, paved roads, letters cut into stone, signals leaping from tower to tower. It is natural to use the mirror we know, but that mirror is small. There is a name for this habit: anthropocentrism, the quiet assumption that human ways of thinking, organizing, and building are the standard by which all other minds should be measured. It narrows the field before the search even begins. If something intelligent once lived here in a very different way, a way that didn't lean on metal or glass, would we have the eyes to notice? A good place to widen the view is at our feet, on open ground where the sun bakes the soil into a crust and scattered mounds rise like small towers. To a hurried glance, they look like heaps of dirt. Inside, a different picture. A termite mound is an engineered space, shafts that pull fresh air down and stale air up. Walls tuned to hold temperature steady, galleries that redirect wind, moisture, and heat with the care of a well-designed building. Termites cultivate fungus in protected chambers, feeding it with chewed plant matter and harvesting it as a stable food supply. No foreman draws a blueprint. Guidance comes from simple rules and shared signals in a crowd large enough to turn local actions into global structure. This is called collective intelligence. Many small decisions weaving a pattern no single termite could plan. Shift from dry grasslands to warm, clear water. A coral reef looks like an intricate rock bed carved by waves in time. It is alive. Billions of coral polyps, each a tiny animal, build limestone skeletons that join to form walls, ledges, and caverns. Fish nursery, wave shield, pantry, city. The reef is all of these at once. It repairs itself, extends where conditions allow, shrinks when temperatures soar, then spreads again. Over long spans, it becomes a geologic feature in its own right, a living scaffold that can persist far longer than most of the structures humans raise. The builders do not sculpt statues or forge tools. They assemble homes from dissolved minerals and sunlight, caught through partnership with algae. Intelligence here is less a plan on paper and more a long agreement between species. Grow, feed, shelter, repeat. Beneath a forest, the ground that looks quiet is threaded with news. Fungal mycelium, fine branching filaments, forms networks that link roots together. Through these threads, trees trade sugars and nutrients. A shaded sapling receives energy from a sun-rich neighbor. A damaged trunk triggers chemical messages that ready defenses in others. The details vary by species, by soil, by season, but the pattern holds. Information moves through an underground web, changing the behavior of the whole. The network has no single brain, yet it routes resources and signals like a living utility grid. If you pulled the forest up like a rug, you would see the weave. Once you start looking for minds that are spread across many bodies, examples appear everywhere. Leafcutter ants farm fungus too, not inside towering mounds but in chambers beneath the ground. The ants trim precise discs from leaves, carry them in lines that look like moving flags, lay the pieces down to feed their crop, and tend the beds with care. Army ants behave like a liquid, forming living bridges with their bodies to allow the colony to flow across gaps. Slime molds, single cells most of the time, merge into a temporary creature that lays a trail through a maze by leaving behind a chemical record. In tests, it finds the shortest path, without anything we would call a brain. Beavers dam rivers and change floodplains, raising water tables and shifting the mix of life upstream and down. The record of their work is stamped into sediments and tree rings. Prairie dogs alter soils by excavating and mix plant communities through grazing patterns. None of these are cities in the human sense, yet each is a sustained redesign of a landscape by a community that shares information. Even in the sea, where stone would sink and fire is difficult, culture thrives without architecture. Humpback whales sing patterned songs that can spread across entire ocean basins and evolve from season to season. Bowhead whales carry melodies so long and complex, they feel like tapestries made of sound. Dolphins teach the young to use sea sponges as tools to protect the face while foraging along rough bottoms. Orca groups have hunting traditions so distinct that biologists recognize them like regional cuisines. Each pod carries a menu, a dialect, a way of moving through a shared world. None of these leave durable artifacts. The traces are behavioral, passed in memory from elder to youth. On land, too, intelligence appears in quiet forms. Elephants remember waterholes across decades and are guided by matriarchs who recall paths to safety long after drought has erased tracks. Crows, especially the New Caledonian crow, bend twigs into hooks and teach the method to their young. Ravens cache food, recall who watched them hide it, and decoy onlookers with fake stashes. Parrots invent new calls that spread like slang through flocks. Octopuses explore with curiosity, unscrew jars, and solve puzzles with flexible arms that feel as much as they grasp. Many of these feats leave no fossil. A clever solution today is gone tomorrow unless someone learns it, remembers, and repeats. Culture without paper. All of this matters for a simple reason. If we only search for intelligence by looking for familiar things, metal tools, carved stone, written marks, we may miss it when it isn't trying to look like us. A past civilization might have built with materials that do not survive, or woven its skill into living systems that leave only subtle chemical changes behind. Imagine a lineage that preferred wood, plant fibers, or resins, shaped with heat and pressure. In a rainforest, those structures could vanish within decades and leave almost nothing behind after a century. Imagine an aquatic species that manipulated currents, sound, and light in water rather than stone on land. The ocean takes back what it is given. It reworks shorelines, buries, dissolves, and recycles. A society in such a world might be almost invisible to the rock record. There is also the bias of scale. Archaeology loves big things, large walls, heavy stones, broad pavements, yet complex life often builds small. Bee comb is delicate and can be eaten away quickly. Wasp nests decompose, spider silk vanishes. Even termite mounds, which can fossilize under special conditions, usually return to dust. If we imagine a civilization that lived close to the ground, preferred perishable materials, and valued mobility over weight, its footprint could be slight, even at great numbers. The absence of large ruins is not proof of absence. It may be a function of the materials and habitats chosen. Another bias lives in the way we define technology. We think of machines, engines, circuits, but technology at its heart is a set of techniques, ways to do work, to store and transmit information, to reshape the environment for a goal. A fungus garden run by ants is a food technology. A coral partnership with algae is an energy technology. An elephant's social map is a navigation technology. A whale song that carries half an ocean is a communication network. If a species learned to harness and steer biological systems with precision, it might leave less trash than we do and still be highly capable. A civilization rooted in biology could be legible only to someone who knows to check the chemistry of ancient soils, the timing of blooms and burns, the spread of a particular symbiotic pair through a region where it does not fit the climate on its own. Even in the rocks we already study, there are signs of behavior without bodies. Trackways, footprints, crossing a wet shore that later hardened, preserve a pattern of movement long after the animals involved turn to dust. Burrows, nests, bite marks, tool wear on bones. These are called trace fossils. They are not the creature itself, but the record of what the creature did. If we were to look for a non-industrial intelligence in deep time, trace patterns might be all we could hope to find. Repeated burning in a landscape that doesn't match lightning patterns. Sediments showing regular damming and release in basins far from beaver range. Pollen records that suggest deliberate tending of certain plants. Microlayers, rich in soot at intervals, that look like scheduled land management rather than random fire. Each on its own could have natural explanations. Together, across a broad region and long period, they would begin to look like intention. The difficulty is that nature is inventive and noisy. Volcanic ash can look like soot. Drought can mirror the effects of overgrazing. Floods can sort sediments into tidy layers. Coral can raise coastlines on its own timetable without a clear, unique signal. An alloy not made by geology. A molecule that does not arise in nature. We tread a thin line between curiosity and projection. Still, asking the question refines the tools. It tells us to catalog the ways life can reorganize matter at scale and to keep those effects in mind when we read the rocks. It also helps to admit how much of intelligence never meets stone. Culture stored in bodies and passed by teaching does not fossilize. Songs do not turn to mineral. Dialects do not set like mud. If a lineage advanced to rich language but never wrote it down, if it mapped the world but never cut it into tablets, if it built homes from woven plants and stored knowledge in memory, there could be 1,000,000 years between then and now with almost no trace. The one thing that might remain would not be a library, but a layer, a thin band in sediments where something about the chemistry of rivers and soils changed for a while because of how life was being lived. There is another trap set by our own habits. We often measure sophistication by energy use and speed. Faster machines, hotter furnaces, brighter nights. Yet great stability can be a higher art. A civilization that learned to keep ecosystems steady through careful feedback could last while leaving little behind that looks like havoc. In the record we are writing, future readers will see abrupt spikes, plastics, nitrogen from fertilizer, a rush of carbon from fossil fuels, radioactive isotopes from tests and accidents. A different approach might aim for balance. Waste that is food for another process. Materials designed to decay on cue. Cities that grow like forests and vanish like them too. To us, from inside our own moment, such a path might look like absence. To the planet, it would look like harmony. None of this argues that there was such a civilization. It argues that our search image, the mental picture of what to look for, needs more shapes. If earlier intelligence existed, it might have nested inside forests, spread across reefs, or moved with migrating herds. It might have expressed itself in choreography and sound instead of stone. It might have preferred soft power to hard edges. Recognizing it would require us to think like naturalists and geologists at the same time, to trace food webs, river chemistry, and fire regimes with the same care we give to counting coins and bricks. Approaching the question this way has a second, quieter benefit. It makes us better readers of our own time. When we pay attention to the intelligence of other life, to the way information moves in groups without central control, to the craft of building with water, wind, roots, and rock, we learn new patterns. We see how a stable temperature can be held with shifting air, how a city can be grown from minerals in the sea, how a communication network can spread across miles without wires. Think for a moment of our own presence, folded into deep time. If you removed the people from a modern port city, the ships would rot, the cranes would collapse, the towers would fade. In 1,000 years, fish would move through flooded basements. In 1,000,000, a cliff might hold a thin line of unusual chemistry, a little more plastic, a different balance of carbon, a dusting of industrial metals. A careful mind could know that something unusual happened here. The rest, language, stories, laughter, fear, would be gone. This is not a tragedy, it is a measure of scale. the story does not end with recognition alone. On a restless planet, every experiment in intelligence is tested by change. Climate shifts, seas move, continents drift. Sometimes the test is slow enough for life to adjust. Sometimes it is abrupt. History, seen in stone, has chapters where much ends at once. After those endings, new arrangements take the stage. If minds have bloomed more than once, many may have met their limits not in war or failure, but in the larger cycles of the planet itself. The rhythm of rise and loss is written into the ground. With that rhythm in mind, the question of who came first softens into a wider view. Intelligence is a property life can reach by many paths. It can pool in a single skull, or it can spread across a colony. It can leave roads and towers, or it can leave a reef. It can burn bright and loud, or hum along for ages almost unseen. Whether we would recognize a very different civilization depends on how well we learn to listen. Not only for our own echoes, but for signs that another kind of mind once shaped the world in its own image, and then let the world take it back. Outside the window, night settles, and with it the sense that time is longer than any single life or story. Somewhere in that long sweep, living systems try on new forms of thought. Some rest lightly and pass. Some build deep and endure until the ground itself moves beneath them. What remains after each attempt is not a monument, but a changed pattern, in soil, in water, in the memory of other living things. From those patterns, the next chapter grows. Earth keeps time in chapters, not calendar pages, but layers of rock. In those layers, the quiet rhythm of everyday life is punctuated by abrupt lines, thin boundaries where many voices stop at once. Paleontologists have a name for those breaks: mass extinctions. They are intervals when the background murmur of species appearing and disappearing is drowned out by a roar, and a large share of life vanishes in a geological instant. Between these endings, new begins. Forests regrow in different shapes, oceans fill with unfamiliar swimmers, and the cast on life's stage changes so completely that earlier acts feel like a memory from another world. To understand how deeply the planet resets itself, it helps to visit the 5 great die-offs that scientists agree mark the sharpest turns in the story. Each one had different causes and different victims, yet all share the same structure. Stress rises, ecosystems unravel, and then, after the crash, the survivors inherit a quieter planet, with room to experiment again. In that open space, entire ways of living are reborn. The first of these upheavals arrived during the late Ordovician, roughly 445 million years ago. Life then was mostly an ocean affair. Shallow seas covered wide continental shelves, and they teemed with trilobites, brachiopods, corals, and the early relatives of fish. Gondwana, the bulk of the continents, had drifted over the South Pole. Ice sheets grew. With so much water locked in ice, sea levels fell, shrinking those fertile, sunlit shallows that so many creatures depended on. When the climate swung back and the ice retreated, the seas rose again in a pulse that flooded coastlines and stressed what remained. 2 blows in quick succession, cooling and then a rapid swing back, were enough to remove around 4 of every 5 marine species. The reefs emptied, food webs collapsed. Yet within a few million years, new communities took hold. The ocean rebuilt itself, with different proportions and new designs. The boundary marking this event is thin on the page of time. Its consequences lasted far longer. The next crisis, late in the Devonian, around 375 to 359 million years ago, was less a single hammer strike than a long drumroll of stress. Plants had colonized land in force. Their roots weathered rock, pulling nutrients into rivers and seas. In many regions, that extra nutrient load fed algal blooms, which, when they died and decomposed, robbed the water of oxygen. Scientists call this anoxia, water so starved of oxygen that animals cannot breathe. Layer upon layer, entire basins went still and dark. Massive reef systems, the living architecture of the Devonian seas, collapsed and did not recover for ages. Armored fishes flourished, then thinned. The toll was heavy, though it came in pulses over millions of years. On land, in the margins between water and air, strange experiments were underway. Lobed-finned fish were trying out limbs. The first tetrapods hauled themselves onto mudflats, breath held in lungs rather than gills, shouldering a new future. The Devonian is often called the Age of Fishes, but its drawn-out crisis set the stage for forests and four-limb walkers to spread. Then came the hardest winter of all. About 252 million years ago, at the end of the Permian, the planet experienced its worst-known extinction, so severe that paleontologists simply call it the Great Dying. The land shook with fire for a long time. In what is now Siberia, volcanoes poured out sheets of lava staggering in scale, not for weeks or months, but for hundreds of thousands of years. The air filled with carbon dioxide and other gases. Oceans warmed and turned acidic. Their circulation slowed, until deep waters lost oxygen. In some places, conditions may have gone beyond mere oxygen loss to something far more toxic, with hydrogen sulfide rising from stagnant depths. Coral reefs vanished. Trilobites, which had survived crisis after crisis for 270 million years, disappeared entirely. On land, forests fell silent. Insects, usually resilient, were cut down to a handful of hardy lineages. By the time the world was finished reshuffling, more than 90% of marine species were gone, and roughly 70% of land species with them. There's a term for what followed: disaster taxa. After the Great Dying, tough, unglamorous survivors like the tusked, barrel-bodied Lystrosaurus spread across entire continents, filling spaces left by the lost. Riverbanks, once held by deep roots, were scoured, mud washed into seas, microbial mats. The earliest kind of ground cover on the young Earth returned to places where forests had stood. It looked for a while like the planet had gone backward, but emptiness is opportunity. Early ancestors of crocodiles and dinosaurs, part of a larger group of reptiles that walked upright, found room to diversify. The reset, as brutal as it was, opened the path that would lead to a new world order. The next cliff in the record, about 201 million years ago at the end of the Triassic, coincided with the first cracks as the supercontinent Pangaea began to split apart. As those rifts opened, enormous volcanic fields bled lava across what would become the shores of the Atlantic. The air loaded with carbon dioxide again. The climate wobbled. Large amphibians and many reptile groups that had dominated rivers and floodplains dwindled. In the clearing that followed, dinosaurs expanded rapidly, taking over niches on land, in the air as pterosaurs, and later in the water as marine reptiles. Early mammals already existed by then, clever and small, mostly nocturnal. They watched from the shadows and waited. The most familiar catastrophe sits at 66 million years ago. The border between the Cretaceous and what followed, dinosaurs, apart from the line that would become birds, ruled rich landscapes. Flowering plants had spread. Insects were abundant. Seas were full of ammonites and reptiles. Then, in a span too short to measure with rock, everything changed. A large asteroid struck the Yucatan, punching a crater more than 100 kilometers across. The impact vaporized stone, sent shockwaves around the globe, and lit forests. Dust and tiny glassy droplets rained down. Sunlight dimmed. Temperatures plunged. In the thin line of clay that marks this boundary worldwide, geologists find iridium, a metal more common in meteorites than crustal rocks, shocked quartz, and spherules that formed from molten spray. The combined stressors, brief darkness and cold, then a greenhouse spike as carbon from burned biomass and disturbed rocks loaded the air, brought down 3/4 of species. The great non-avian dinosaurs did not survive. Birds did. So did crocodiles, turtles, and many small mammals. In the quiet that followed, mammals spread into forms that had not been possible before. Grazers of open grasslands, swimmers that returned to the sea, flyers of the night sky. Primates arrived later, and from them, eventually, us. Across these 5 events run a few shared motifs. One is pace. To a geologist, sudden can mean tens of thousands of years. To ecosystems, that is a blink. A reef or forest can absorb slow change. It cannot handle a swing that outpaces the generation times of its key species. Another is the cascade. Remove a few foundation builders and entire communities collapse. Reef architects die, and with them go the fish and invertebrates that depended on them. A similar cascade happens on land if pollinators crash or large plants fail. A third motif is opportunity after loss. Once the dust settles, the planet is less crowded. The survivors radiate into empty space. Paleontologists see a Lilliput effect. After many extinctions, body sizes shrink for a while as food webs restabilize, followed by expansions into new designs. That cycle contraction, then inventive radiation, writes itself again and again in stone. If we step back from the particulars and look at the outline of these resets, a question rises that touches our theme. After each crash, there was a long interval when new forms could try on strategies. Intelligence, in many shades, is one such strategy. Tool use, social learning, long memory, planning. These traits have evolved multiple times in different groups: cephalopods, corvids, elephants, primates, some toothed whales. The idea that minds can bloom is not unique to one branch of life. It is plausible that in earlier intervals, those vast reaches between the Ordovician recovery and the Devonian reefs, or the long Triassic hang time before dinosaurs took over, cognitive experiments we can scarcely imagine unfolded and then winked out. A lineage of coastal foragers might have learned to pass down fine-grained maps of tides and shell beds across generations without ever carving stone. A social reptile could have engineered burrowed landscapes, the way prairie dogs and beavers do now, on a scale large enough to shape local hydrology, then fall into a climate swing that dried its range. In the sea, a schooling hunter with a big brain might have developed regional dialects and seasonal knowledge that rival our own flux of culture, leaving behind no more than patterns in the chemistry of ancient shells. Would such experiments leave marks we could read? Very few. The fossil record favors bones and shells, not behavior. Even where behavior leaves a signature, it is usually modest: a run of burrows through a storm bed, a clutch of eggs with a circle of footprints around it, a nest scraped into sand. The more a culture lives in memory and schooling rather than in stone, the less likely it is to meet future eyes. That does not make it small. It makes it quiet in rock. Each great die-off also reminds us that intelligence, however flexible, is nested in climate and chemistry. The late Devonian crises turned basins anoxic, making large areas of the sea uninhabitable. The Permian added heat and acidification to lack of oxygen. Even the best problem solvers cannot breathe where oxygen is gone. The end Triassic battered life with greenhouse spikes tied to continent-splitting volcanism. The end Cretaceous pulled light from the sky abruptly enough to break food chains that depended on photosynthesis. Minds cannot plan their way around the removal of basic fuel. The stage matters, and sometimes the stage itself tilts. There are traces, faint but telling, that reveal how ecosystems restart after endings. In the rock just above the Cretaceous impact layer, there is often a fern spike, a sudden surge in fern spores. Ferns are pioneer plants. They rush into burned areas and ash-covered ground. Their brief reign in the record is a sign of forests gone and a world resetting. After the Permian, river deposits in many places show more mud and fewer plant fragments, a hint that deep-rooted trees were reduced and the land eroded more easily. Microbial mats grew where complex vegetation had been, turning flats into slicks and trapping ripples that later preserved as textured stone. In the earliest Triassic, bones of Lystrosaurus dominate some beds, a single, tough herbivore doing the rough work of grazing in empty landscapes. Later, diversity climbs again, slowly, like a patient breath after a long hold. Patterns repeat, but not perfectly. That irregularity is important. It means the planet is not running a rigid clock. It is responding to the mix of continents, airs, and seas present at each time. Some researchers have noticed hints of periodicity in extinction intensity, suggesting a possible long rhythm tied to orbital cycles or galactic motion, but the details remain debated. What is certain is that stressors can stack. A long volcanic episode can weaken ecosystems so that a later shock, like a sudden climate flip or sea level jump, pushes them past the edge. When too many layers of difficulty arrive together, resilience gives way to collapse. All of this may sound distant, yet it loops back to a personal scale. Our own era registers change at a speed many species struggle to match. Warming is quick, seas are inching upward, and the chemistry of the air and water is shifting. Scientists speak soberly of a sixth mass extinction in progress, driven by habitat loss, climate, and overuse. That idea, even spoken quietly, is heavy. Still, the older story holds a form of comfort. Life recovers. Not the same life, not the same arrangements, but something grows again. The planet's habit is to refill, to diversify in new directions when a ceiling falls away. If we care which directions those are, our work is in the present, in the practical acts that slow the swing and give living systems room to adapt. There is a gentler way to hold the thought of earlier minds in this light. Instead of picturing lost cities under stone, picture seasons of attention, an age when groups tracked winters with stories and moved herds by memory. An age when a coastal animal mapped currents and learned cues, passing them in play and song. An age when a forest-dwelling creature shaped its undergrowth with fire in careful intervals, keeping its home mosaic of open and shaded patches. Each would have seemed as lasting to its makers as our networks feel to us. Each could vanish in an interval, like the end Triassic or the end Devonian, leaving behind only a slightly altered pattern of charcoal bits in soils, a pollen curve that rises and falls with an odd cadence, a sediment series that hints at repeated water level changes that don't match the local climate model. To read those faint signatures as culture would require a broad, patient eye and a humility about what counts as civilization. All 5 great extinctions lead to the same closing insight. Earth is not a place where one way of living wins forever. It is a place that resets. The winners of one era are swept away, and lineages running in the background step forward. Dinosaurs rose on the open field left by the end Triassic. Birds survived where their cousins did not at the end Cretaceous, and inherited the skies. Mammals filled the quieted forests and plains, and tried on many shapes. Intelligence, too, follows these waves, gaining room in some eras, losing ground in others. If it has appeared before, the record would be simple, sparse, and easy to miss. The absence of familial ruins would say little. The planet does not keep libraries, it keeps layers. Stepping back even farther, the pattern of break and bloom is not peculiar to one world. Other planets change, too. Some dry out, some overheat. Some perhaps carry long, quiet periods where life can take its time. Around distant suns there will be their own chapters of fire and ice, their own sudden boundaries where many voices stop. If intelligence flickers there, as it does here, much of it will live between those lines and be erased by them. That is not a loss, so much as the fabric of a restless universe in which making and unmaking are paired. Night stories often end with answers. This one prefers a wider frame. Life writes in eras, not in straight lines. The record the Earth keeps of those eras is uneven, sometimes generous with detail, sometimes stingy. From that record we know there have been at least 5 moments when the page almost turned blank. After each, the handwriting changed. Whether minds like ours ever practiced the craft in an earlier script is a question that stays open, not for lack of wonder, but for lack of ink that lasts. The next scene belongs to a larger stage, one where other worlds carry their own eras and where the silence between them may be a matter less of emptiness than of timing. When we look up at the night sky, it is easy to forget how small we are. The Earth beneath us feels immense, filled with continents, oceans, and towering landscapes. But in the cosmic sense, our world is a tiny point, circling an ordinary star on the edge of a galaxy that itself is just one among billions. This perspective shifts our thinking. If civilizations can rise and vanish here, on one fragile world, then surely the same could be true elsewhere. And if so, what would remain of them now? Our closest neighbors already tell stories of change. Mars, the red planet, appears today as a cold desert. Its surface is a windswept wilderness of dust, craters, and canyons. Yet scattered across this barren world are clues that it was once very different. The dry channels etched into its surface are unmistakable signs of rivers that once flowed. Minerals locked in Martian rock reveal they were formed in the presence of water. At the poles, layered sheets of ice gleam in the thin sunlight. Billions of years ago, Mars may have had a thicker atmosphere, lakes, perhaps even oceans that stretched across its lowlands. For a time, it might have been far more like Earth. If life had a chance to begin anywhere beyond our planet, Mars would have been one of the best candidates. Some scientists imagine microbial life clinging to its rivers or shallow seas, sheltered from radiation. If that ever happened, what would remain after billions of years? Mars lost its protective magnetic shield, leaving its air vulnerable to the solar wind. Over time, its atmosphere was stripped away, and with it went its water. Today, any traces of past life, even the simplest, would be hidden far underground, shielded from the harsh surface. And if by some unimaginable chance something more complex had once existed there, it too would now be invisible. Stone crumbles, winds scour, dust buries. Even a city of towers left for ages on Mars would have been ground to sand by now. The silence we see is not proof that nothing ever lived there. It may simply be the effect of time. If Mars is a frozen memory, Venus is the opposite, a world transformed by fire. Slightly smaller than Earth, it is often called our sister planet. But beneath its clouds lies an inferno. Temperatures sear hot enough to melt lead. The air is so heavy it would crush us, thick with carbon dioxide, laced with sulfuric acid. To land on Venus is to enter a furnace where nothing human could last. Yet, long ago, things may have been different. Some models suggest Venus once had oceans, shallow seas glinting under a gentler sun. For millions of years, it may have been habitable, as Earth is now. Then something shifted. As the planet warmed, water began to evaporate. Water vapor itself traps heat, and as more evaporated, the planet grew hotter still. With oceans gone, carbon dioxide built up unchecked. Volcanoes reshaped the surface, burying older terrain. In time, Venus became the furnace we see today, its past erased. If life ever began there, its traces are long gone, burned away or sealed under layers of lava. These two neighboring worlds remind us how fragile conditions can be. Mars dried out, Venus overheated, and both are now hostile. Earth is balanced between them, with oceans and an atmosphere just right for life. But the comparison is humbling. Our stability is not permanent. What happened to Mars and Venus could, under different circumstances, happen here. Civilizations are not only vulnerable to their own mistakes, they are at the mercy of planetary change itself. When we look beyond our solar system, the possibilities expand dramatically. In just a few decades, astronomers have found thousands of exoplanets, worlds orbiting distant stars. They are discovered in many ways: by watching for the faint dimming as a planet crosses its star, or by detecting the wobble in a star's motion caused by an unseen companion. These discoveries reveal something astonishing. Planets are not rare, they are everywhere. In fact, there may be more planets than stars in the galaxy. The variety is staggering. Some are hot Jupiters, giants that skim so close to their stars they are blasted by radiation. Others are super-Earths, rocky worlds larger than ours, some orbiting within the gentle range where liquid water could exist. There are planets covered by deep oceans, perhaps stretching from pole to pole. There are frozen worlds, scorched worlds, even planets drifting through space without a star at all, warmed only by their internal heat. Among the hundreds of billions of planets in our galaxy, billions may sit in zones where water, and therefore life, is possible. With such numbers, it seems unlikely that Earth is the only place where life has ever appeared. And if life is common, then intelligence, though rare, might have emerged many times. Civilizations could have risen under alien skies, developed knowledge, built structures, perhaps even reached space. But across the expanse of cosmic time, how many of them would still be here? Civilizations may last centuries or millennia, but stars burn for billions of years. In that vastness, even long-lived societies are but sparks. They flare, shine, and fade. If one existed 100 million years ago on a distant world, we would see no sign of it now. Its monuments would be gone, its signals long faded into the static of the universe. This raises the question of the silence we hear. With so many planets, why do we not detect others? This puzzle is known as the Fermi paradox. One answer is that civilizations are indeed rare. Another is that they are fleeting. Perhaps many have existed, but at different times, separated not by distance but by eras. They do not overlap. By the time one arises, another has already vanished. To us, the stars seem empty, but perhaps that emptiness is simply the space between echoes. Even the stars themselves shape this rhythm. Some stars live long and quiet lives, burning steadily for tens of billions of years. Others blaze hot and fast, ending in violent explosions after only a few million. Planets caught in these different orbits share their fates. Some enjoy stability for eons, others are destroyed almost as soon as they form. Civilizations that rise under these suns are tied to their lifespans, just as we are tied to our own. Seen this way, Earth is not the center but one of countless experiments, a planet balanced just right for just long enough to allow intelligence to bloom. The fact that we are here, able to ask these questions, is remarkable. Yet in the cosmic perspective, it is also fragile. If civilizations can vanish on other worlds, they can vanish here too. The lesson is not that we are unique, but that we are temporary. Perhaps civilizations across the galaxy are not rare, but transient, sparks in the dark, each one shining briefly before fading, leaving behind only silence. The miracle is not that we are the only ones, but that for this moment, on this small blue planet, we exist at all. If we allow ourselves to imagine that we might not be the first civilization to walk this earth, the thought does not diminish us. Instead, it expands the horizon of what it means to exist here. It means our story, as grand as it feels in the moment, may be one chapter in a book much thicker than we ever guessed. Civilizations may come and go, each one certain of its permanence. Each one convinced that its achievements will last, yet in deep time, permanence is an illusion. Look at the ruins we can already see with our own eyes. Stone cities built thousands of years ago now stand as weathered fragments, half reclaimed by soil and roots. Great roads that once carried armies and merchants are broken paths walked by tourists. Languages that once commanded empires are now studied only by scholars. Even in spans of mere centuries, the signs of once mighty civilizations blur and fade. Scale that to millions of years, and the traces almost certainly vanish. If we are not the first, then perhaps countless experiments have unfolded here before us. Species rising to awareness, shaping their environments, building something that to them felt like destiny. They might have lived for centuries or millennia before time and catastrophe swept them away. We may never know their names, their dreams, or even the shape of their bodies. The record of their existence may be gone, recycled into stone and soil, but their possibility lingers, reminding us that our story is not the only one Earth could tell. There is humility in this thought. We live in an age where our influence feels immense. We split atoms, we send machines to other planets, we cover the globe with networks of communication. It feels unshakable. Yet the same laws that erased earlier ages still apply to us. Our cities, our technology, even our languages will not last forever. The forests will return. The mountains will shift. The seas will carve new coastlines. Long after we are gone, the earth will continue to write its own story, indifferent to the traces we tried to leave behind. Civilizations, no matter how brilliant, are temporary patterns in a much larger system. They rise when conditions are right, when climate is stable, when resources are abundant, when cooperation holds, and they fall when those conditions change. It has happened before on smaller scales with cultures we know. It could happen again with us. In that sense, the idea that we are not the first is not only possible, but consistent with everything we see around us. The universe is not built for permanence, it is built for change. Yet there is something quietly comforting in that truth. If our story is just one among many, then we are part of a larger rhythm. The earth itself is the constant, the stage upon which countless actors come and go. Forests rise, are burned away, and rise again. Oceans expand and retreat. Mountains thrust upward, crumble, and are born again. Civilizations, too, may follow that cycle, their memory fading, but their impact folded into the next layer of the planet's evolving surface. What matters, then, is not the illusion of permanence, but the beauty of the moment. For this brief span of time, we are here, able to ask questions, able to wonder about those who may have come before, and those who may yet come after. We are able to leave our own fleeting mark, not on stone or steel, but on the shared awareness of what it means to exist. If future beings one day walk the earth, they may not know us. They may find no trace of our monuments, no clear record of our lives. But perhaps they will feel what we feel now, a sense of standing on ancient ground, of being part of a story deeper than any single age. In that recognition there is continuity, even if the names change. The quiet truth is that Earth does not need us. It did not need those who may have come before, and it will not need those who come after. It will go on, reshaping itself, welcoming new forms of life, writing new stories in rock and ocean. The stage is vast, and we are but one performance. But while we are here, we can marvel at it, honor it, and add our voices to its chorus. If we are not the first civilization, then we walk in invisible footsteps, sharing the stage with forgotten actors. If we are the first, then we are pioneers, carving the opening act of what may be a much longer story. In either case, the lesson is the same. What matters is not how long our mark endures, but that we lived, that we created, that we ask the questions only conscious beings can ask. As this reflection draws to a close, the thought settles gently. Civilizations rise, civilizations fall, but the planet continues. The rivers keep flowing, the forests keep growing, the stars keep burning. In that vast rhythm, our time is small, but it is ours, and for now, that is enough.